Okay, so the second of the rules that we're looking to learn is called the product rule. And as it sounds, if we have two functions multiplying each other, all right? So sometimes it's quite possible you could argue you could join the functions together and turn them into one function, which is, quite possibly the case here. Oops. We could certainly treat them and join them together, but something like this, no. And so often the examples or the questions in it, maybe you got something like that where you've got an exponential times a cos, or we've got a sine times a cos, or we've got x squared times e to the x, okay, where you've got two distinct functions. So if we've got two distinct functions, well, that's when we need a product rule, because these are multiplying each other, all right? So my product rule is when we have two functions multiplying each other. And so what the rule is, it's another way of writing the rule. This is my formula sheet rule. If we have two functions u and v, my derivative is the derivative of u times the function v plus the derivative of v times the function u. So for me, it's derivative of the first times the second plus derivative of the second times the first. And typically the easiest way to approach it is to identify your two functions. One function there is 2x minus 1. The second function v is, we'll write it as x to the half, which means u dashed. Derivative of u with respect to x is simply 2. And v dashed is equal to a half comes out the front, x, take 1 off the power. All right. So there's the four functions I'm going to use. So now let's just change let's just change them a fraction. I'll put them in different colors to help us. So we said u was equal to x to the half, and v dashed is 1/2 x to the minus a half. All right, because now my f dashed of x is equal to the derivative of the first, so we'll call that u. So u dash 2 times the second function. The second function is simply just x to the half plus the derivative of the second function, which is a half x to the minus a half, times the first function, which is 2x minus 1. All right, so there's the first function and its derivative. There's the second function and its derivative. All right, so once you've done that, you then just add the functions together. So that gives me 2x to the half plus, I don't know if there's much, the x to the minus a half could go on the bottom perhaps. So we might write that as 2x minus 1 over 2 root x. But there's maybe not a lot we can really do with that. Maybe you could take your, do we want to do that? You probably could. All right, so a simplification method that we probably should get in the habit of. Let's just go back and in here, let's change that x to the half to the square root of x, all right? So we've got root x in both, so let's just see how this works for us. So I actually can take the square root of x out the front, all right? Now what that means is I've got 2 root x here, but because I've taken that square root of x out the front, to keep this equal, I'm also going to multiply by square root of x. So there's the 2 root x that I started with, and the red root x's cancel each other. So it's the same expression, but you'll notice root x times root x actually is an x, so that'll make that a bit simpler. And then I've got plus over here that expression, well, the root x is already gone, so I get 2x minus 1 over 2. So what can we do there? Well, let's write it as 1 over the square root of x outside of root x times root x is x, so that's 2x there. Divide it to everything by 2, I get plus x minus a half. So I get 1 on root x times 3x minus a half. So possibly the half could come out the front to make it 1 over 2 root x, and that might make it 6x minus 1. All right, so two parts about this problem here. The first of those is, are we okay with it to here? All right, and if we're okay to there, that means the product rule was okay. If this part here is a bit confusing, that's our algebra skills, and we will get better at that. All right, we've just got to keep practicing, all right, especially with the product rule, because we'll find there's a little bit of factorizing that we can do. Let's do the same thing again on the next one. We'll call that the red function, and we'll give that green. All right. So let's go with the red function. U is equal to x squared minus 1 all squared. So then u dashed is equal to the derivative of that. So remember, 2 comes out the front, x squared minus 1, take 1 from the power, times the derivative of the inside, which is 2x. So that's equal to, what's that going to give me? That's going to give me 4x out the front of x squared minus 1. All right, so there's my u function and its derivative. Let's go to the green function. We'll call that v. And v is equal to 2x minus 1 cubed. The derivative of that v dash is equal to 3 out the front, 2x minus 1, take 1 from the power, times the derivative of the inside, which is 2. So that gives me 6 times 2x minus 1 squared. See how we go for room here, gents. So my derivative is given by f dash of x is equal to the derivative of the first function, which is 4x times x squared minus 1. Derivative of the first times the second function, which is 2x minus 1 cubed, plus the derivative of the second function, which is 6 times 2x minus 1 squared times the first function, which is x squared minus 1 squared. All right, so let's stop there again. We'll give it a little yellow. That's my product rule. If where each of the terms come from is okay, well then we're okay with the rule. Now we'll do some factorizing. Now with my product rule, often we can see each of the functions are present in each section. So there's an x squared minus 1, there's an x squared minus 1. There's a 2x minus 1 cubed and a 2x minus 1 squared. So often they're my common factors that can come out nicely. So let's get rid of that. Equal to. So let's take out x squared minus 1, which is there. And I've got a 2x minus 1 squared common to both, which is there. So if I go to the first term, what have I got left? I've got x squared minus 1, so I've got a 4x in red still. And I've got a 2x minus 1 squared, which means I've still got a 2x minus 1 left. Plus, well, I've got that green 6, it's still there. 2x minus 1 squared, 2x minus 1 squared, so that's okay. I've got an x squared minus 1 here, but I've got an x squared minus 1 squared there, so I've got an x squared minus 1 left over. So now that means I've got x squared minus 1, 2x minus 1 squared. Expand that bracket. So what does that give me? That gives me an 8x squared minus 4x plus 6x squared minus 6, which gives me x squared minus 1, 2x minus 1 squared times 8x squared and 6x squared is 14x squared minus 4x minus 6. Obviously, there's a 2 there that's a common factor. Oh, I wonder if that factorizes. So let's take the 2 out. Let's just bring that up here, up to the top left. So 14x squared minus 4x minus 6. 2 comes out the front for a 7x squared minus 2x minus 3. 7x and 1 cross multiplied with, it's just 3 and 1, isn't it? That's not going to work anywhere, is it? No. So that doesn't factorize nicely, so we don't have to worry about that. So we can really leave that as our final answer. All right. So there's my product rule.